Dear students, today I will discuss about a very fundamental concept of mechanics, especially you can say the dynamics, special concept of dynamics, that is force. When you are going into mechanics or a branch of mechanics, that is dynamics, then the concept of force is very useful, and actually this is a very needful concept. You need to know about force when you are going to talk about dynamics, because dynamics start with the concept of force. And this is a very popular concept because the very famous scientist Newton's name is always come into the picture when we are talking about force. So in this video, I like to discuss more about concept of force, and let me discuss this fundamental concept of physics or mechanics with the help of these examples. Okay, so I have taken 4 cases. This is a very popular example that initially I have kept a block of mass m on a horizontal surface like this, and initially it is at rest. Now if I give a push or pull on this object of mass m, then it will start to move, and initially it is at rest. That means its velocity is 0. It may be happen that if you give a push or pull, then also it is not going to start actually initially, but if you give more push or pull, then it will start to move. So you can say that if a push or pull is given to this object, the object will start to move. Now what will be its movement? That is, its movement is more faster than initial, or maybe it more slower than initial. It depends on in which direction or how much push and pull you are giving. So now let me give a push or pull in the direction of its motion. Let me assume that this block has a velocity v initially, and now I am giving a push or pull in the direction of its velocity. Then what will happen? Its velocity will increase, and I am assuming that its velocity will twice v, that is this velocity is increased double to its initial velocity. Now in the same case, if the velocity is already 2v, and if I give a pull or push in the opposite direction to this velocity or its direction of motion, then what will happen? Its velocity will decrease, and let me decrease to v from 2v. But if we apply the push or pull in the direction perpendicular to its motion, then it may be happen that its velocity, the magnitude of velocity is not changing, but its direction changing. The direction is changing. So all possible cases may be happened, and it completely depends how much push or pull you have given, or how much push or pull in which direction you are giving. So its future path or its future motion, it depends on the pushing or pulling, and also the direction of pushing or pulling in with respect to the direction of its initial velocity. So in terms of velocity, what we are going to say, or what we want to say in terms of velocity, that in which state of motion the particle or the block or the system is in. Here actually, if I say that the particle is at rest or the block is at rest, that means its velocity is 0. So in terms of velocity, we can express or we can explain the state of the object and actually the state of motion of the object, because if it is at rest, that also the state of motion, because when it is at rest, its velocity will be 0. So this is also a state of motion, and the state of motion is here at rest. But the state of motion here is the increasing velocity. Its velocity is increasing. That what we call in kinematics, the particle is in acceleration. And here its velocity is decreasing. That means the particles in its state of motion, where its acceleration is when its velocity is decreasing, that means it is in deaccelerated. This is the deaccelerated motion. So whatever I am saying over here, or whatever I want to write in terms of velocity, what I actually want to say, it's state of motion. And in each and every cases, by pushing or pulling to the object, what I am going to change? I am going to change its state of motion. It either may be, and this state of motion of any particle or any block or any system can be completely defined by its velocity vector, because it's a vector quantity, it's a physical quantity which is a vector quantity which has both magnitude and direction. So if we change its magnitude or if we change its direction, that means we are going to change its velocity, completely the velocity vector, either its magnitude or its direction. If we change its magnitude or direction, then actually what we are going to change? We are going to change completely the physical quantity, that is velocity vector. So in all the four cases, you can say we have changed the velocity vector. Here in magnitude, the magnitude is increasing. Here also the magnitude, but the magnitude is decreasing. Here the velocity vector, but not in magnitude, but in direction. So either in direction or in magnitude, by using the pushing or pulling, what we are going to do actually, we are going to change its state of motion. And that pushing or pulling, which actually changes the state of motion of an object in terms of magnitude or in terms of direction. Simply in mathematical language, if we can say that if pushing or pulling change the velocity vector v vector, then we can say that this pushing or pulling as a force. So we can define this thing in this manner, that it is a push or pull which changes the state of motion of the object. So this word, that is state of motion, which is characterized by velocity vector v, is very important here. If this velocity vector remains constant, that we cannot say a force is acting on the object. But if it not equal to constant, that means if velocity vector is changed, then we can say that a force is acting, that is actually the pushing or pulling. So this English language, pushing or pulling, is converted into the physical language, that is force, only when the object changes its state of motion. Okay, so that's why I am writing over here that force is a push or pull which changes the state of motion of the object. But now what will be the future path of this object, what will be the trajectory of this object, or what will be the locus of this particle, it will completely depend on the direction of force and as well as the initial direction of velocity. So it will completely depend on the angle between F and V. This force is written by this English capital letter F, most of the cases. So it will completely depend on the angle between F and V. The trajectory of motion of the object will depend on the angle between F and V. In which direction you are giving the force, that will decide in which path the particle will follow. Okay, so the trajectory of motion with respect to the angle between F and V we will discuss in the next class. Okay, so this is the first class, and